All right, so in the last part, we looked at the order of operations, how they go. So this next part, we're going to take a look at what happens if we have a variable thrown in the mix. If you don't know what a variable is, I guess you can say there's two main things we look at for basic algebra. We have our variables. Instead of just writing it, I'm just going to type it. We have variables, and we have constants. If you don't know what either of these are, let's take a look at the easiest, which is a constant. A constant is a number, so like 0, 1, -5, even 1/2, even pi. It's not a very good pi, but that's pi. A constant is just any actual number. It's called a constant because 1/2 is always going to be 1/2. 1/2 is constantly equal to 1/2. 1/2 will never change. That's why we call it a constant. It's constantly that value. That's constantly a 1. And the other one is a variable. Variables, when you see them, will look like things like an X or a Y, sometimes even a Greek alphabet letter like theta or alpha. But for this class, we're pretty much just going to take a look at things like X and Y. So what a variable is it's like a little placeholder. So if we have an equation like 2x, well, that x is just a way for us saying that we can replace x with like a 1. So we have 2 times 1 or 2 times 2. That variable is just us saying we can replace it with a number. The reason it's called a variable is because its value can vary. It varies depending upon what we plug into it. That x right there, I could plug any number I wanted to into it. So when you see an equation with a variable, just know it's nothing scary. It's just pretending to be a number. Also, one thing to remember is a variable and a constant, they can never be added or subtracted together. They can be multiplied and divided, but never added and subtracted. All right, so let's take a look at an example with a variable. Well, before we do that, so most of the time we have a variable, like in this example here, we'll get to in a second, we're usually going to be trying to solve for the value of that variable, to find what number that actually is. So if you remember when we did the order of operations, it goes parentheses, exponents, multiply, divide, add, and subtract. But since we're trying to solve for a variable, it gets a little different. So we have to do it backwards. So whenever we are doing it backwards, we'll start with subtraction and addition, then divide and multiply, then we'll look at the exponents, and then parentheses. We're probably not going to see too many exponents in this unit at all, but we might see parentheses every now and then. But for the most part, we're going to be looking at the first part up here. So we deal with addition and subtraction, and then multiplication and division. If it's confusing, just hang on. Let's try out an example or two and see how it goes. So in this example here, we're given that x plus 2 is equal to 3. Like I said before, this x is a variable. It means its value varies depending upon the situation it's in. So right now, it has some kind of value that makes this equation true. So we need to find what number we can replace x with that makes this side equal to that side. Easiest way is, again, to look at our reverse order of operations, see if we have subtraction or addition, which we do have addition. So that means we want to get rid of this plus 2. So how do we get rid of things inside of an equation like this? since we're dealing with an actual equation where we have an equal sign involved, we have to do the opposite of whatever's going on here. So this is plus 2. The opposite of plus 2 is minus 2. So we're going to subtract 2 from both sides. Keep in mind, when we subtract 2, we can only subtract 2 from the constant. Never subtract a number from the variable. So we're going to have x is equal to 3 minus 2 is 1. So the answer is 1. If you wanted to check that, then we can take this x and replace it with 1. So if we say 1 plus 2 equals 3. Is that true? Well, yeah. Plus 2 is 3, and 3 equals 3. Okay. So let's take a look at another example. So this one here, we have x minus 4 equals 13. So again, we just look at what's going on over on this side with the x. We have a minus 4, and you want to get rid of that. So the opposite of subtracting 4 is adding 4. And what we do to one side, we do to both. So that's going to be x is equal to 17. And we're done. So now let's take it up a step further. If we notice over here, it looks a little different. We still have a number being added subtracted, but we've also got a number in front of the 2x. So when we have 2x, that's the same thing as 2 times x. Which means we're going to, if we look back to our reverse order of operations, we deal for addition and subtraction first, and then our multiplication and division. So we're not going to worry about that 2 times x until we get rid of that plus 2. So to get rid of plus 2, we subtract 2. So we'll have 2x is equal to 2. Now again, this is 2 times x. So the opposite of multiplying by 2 is dividing by 2. And if we remember, we can use a fraction to represent division. So this is saying 2x divided by 2, the 2's cancel, left with x. Over here, we have 2 divided by 2, which they cancel, and leaves me with 1. And if you don't like using fractions, well, we can try it again. We can say 2x equals 2. You can do a division symbol for both sides if you want to. 2x divided by 2 is x, and 2 divided by 2 is 1. So it's just whichever way you prefer. I used to prefer fractions because once you get the hang of them, they just make life easier. All right, so let's try another one. All right, so again, we're going to deal with the subtraction first. Opposite of minus 3 is plus 3. Plus 3. Okay, so that leaves me with 4x on this side and 8 over here. And again, this is 4 times x. To get rid of that, we have to divide by 4. Which means x is equal to 2. All right, so in the next part, we're going to take a look at the next step, which is what happens if we have a variable on both sides.